Welcome to Functions and Relations. So, when we are talking about functions and relations, the very first thing we need to discuss is a whole lot of vocabulary. A relation is essentially an ordered pair or set of ordered pairs. So, X, Y, for example. Functions and relations can be listed in a variety of ways. A relation can be shown as a graph, as a table. We'll talk about mapping diagrams. Sometimes they're simply just lists of ordered pairs. And occasionally we will even see them in equation format. A function is a very specific type of relation. So it is a relation with exactly one input for every output. In other words, the X does not repeat. Y can repeat a ton of times. X does not repeat ever. Okay? So it is a relation. It's a set of ordered pairs that can be displayed in a variety of ways. Like I said before, graphs, mapping, list of ordered pairs, equations, tables, you name it. We can set up a function in a variety of ways. But very, very importantly, X does not repeat. The input value, our Y, is not, it can repeat, but our output, our X value, must be different each time. A linear function, which we'll get into a little bit more in later lessons, is simply a function that forms a straight line. So a function can be curvy, or it could be just a scatter plot all over the place, but a linear function very specifically forms a straight line. Now, domain and range are going to help us to classify and organize some of our relation information. So, a domain is all of the X values in a given relation. Okay. A range is all of the Y values in a given relation. Couple of random notes. First of all, we can use this symbol to represent all real numbers. If we have a graph, for example, that goes on and on forever and ever and ever and ever and ever and ever and ever, right? All real numbers could be the domain or the range because it continues forever in either direction. Another thing is we sometimes will use our inequality symbols. So, for example, if Y is all of the numbers that are bigger than 0, I will sometimes write a range like this. Or if a X value is anything that is less than or equal to 14, then I could write my domain like that. Okay, so these are some things that you may see moving forward. We're going to focus on the specific lists today, though. So our first example, we have a list. We know that this is definitely a relation, but is it a function? So what we're going to do, we're going to start off, we're going to list our domain. We're going to list our domain, list our range, and then I'm going to tell you what a mapping diagram looks like and show you an example. And then we're going to decide if it is a function or not. Okay. So our domain is going to be listed with a little bracket symbol. I'm going to put an X, and then I'm going to put a vertical line. This means that we're listing the x values, all of our domain values. So I'm going to look at my relation here, and I see in my list I have a 3, a 4, a 5, a 6, and a 7 in my domain, because those are all of the x values that appear in those ordered pairs. So this is all of my x values that I see. Now for range, you probably guessed it, we're going to put y and a vertical line. And we're now going to list all of the y values. Now, I didn't have to worry about it in this one, but notice that the numbers are in order from least to greatest. That is ideally what we do when we list our domain and range. Although if they're out of order, it's not inherently wrong. I just want you to make sure that you get in the practice of least to greatest when you're writing these, unless you're specifically told otherwise. So we have a 4, a 12, a 6, a 7, and a 10. So I'm going to put those in order, and I'm going to kind of mark them off as I go. I have 4, and then 12 is not my next largest. 6 would be. A 7 next, a 10, and then I have that 12. And then I close my bracket when I'm done. Now, a mapping diagram is going to look kind of like this. You've probably seen one before. You might not realize it. I'm going to move that over a little bit so that way I can organize my function then. And what I'm going to do is I'm going to list all of my x values and list all of my y values. And I am going to play connect the dots. So 3 matches up with 4. 4 matches up with 12. 5 matches up with 6. 6 matches up with 7. And 7 matches up with 10. So this is just a nice little visual aid for me to be able to kind of see if something is or is not a function. Because, as I mentioned previously, a function has exactly one, or has no repeating x values, okay? So I can repeat my y values all day. But, so in other words, I could have 3, 4, 5, 6, 7, and then for my x values and for my y value, just have 10. Even if it connected with all those, that is still a function. But I want to know if this one is a function. Does 3 match up with anything other than 4 one time? Does 4 have any more than one partner? Does 5 have any more than one partner? And the answer is no to all of those. We only have each x value appear once for each ordered pair. So that means this is a function. Okay. Yes, it is a function. Has no repeating x values. Okay. All right, I want you to give this a shot. So first of all, list all of your x and y values for your domain. Remember the notation here. Fill that in. Remember least to greatest. And then your mapping diagram. So you're going to put your x values in one, your y values in the other. Play connect the dots there. And then decide if this is a function. Do your x values repeat more than once throughout the relation? And then continue the rest of the video. All right, so this time we are going to take a look at 2 tables. The general concept is the same. We already have our lists for our domain and range, nice and easy for us. But I'm still going to make sure they're in order from least to greatest. My domain is -2, 1, 0, 3. And then I have 3, 2, -1, 1. So I'm going to put those again, least to greatest, -1 first, and then 1, 2, 3. And this time I'm not going to do my mapping diagram. I just want to decide, is this a function, yes or no? And so I'm going to look at my x values. I don't see anything repeating, so this is a function, no repeating x values. There's exactly one input for every output. Sorry, output for every input. All right, so this next one here, we're going to look at again. Domain. I need to put these in order. -4, -3, 0, 2. And then my range is going to be -8, -4, and 6. Now in this case, I do have a repeating 6, right? I have more than one 6 in my y values. But it is still a function because my x values don't repeat. All right. Now, there's a special thing we can do in this case when it comes to graphs. So again, we can look at it, of course, as we have for our other values, and we can just see if there's more than one repeating x value. I'm going to make a table so I can check that out. So my x values are 4, and the corresponding y value is 1. And then I have 8 and 1, and 8 and 2. Then I have 12 and 2, and 12 and 3. And then I have 16 and 4. And I have 20 and 3. Okay, so I'm going to make a list of my domain. My domain is 4, 8, 12, 16, 20. And my range is 1, 2, 3, and 4. Now this one is not a function. I can see that because if I look at my X list, I have this 8 repeating, I have the 12s repeating, and then I know for a fact that that's not. But there is something that we call the vertical line test that we can also use when it comes to assessing if something is a function that is on a graph. So vertical lines, vertical line test, okay? Vertical lines are straight up and down. And this test is that if the line touches more than one point on the graph, it is not a function. Okay? So in other words, if I look at a vertical line here and I see I touched 2 points there are 2 points of contact for data. Therefore, it is not a function. And I can do that in multiple places, right? So if I just look at this first set, that would be considered a function because it's only hitting 1 point. But as soon as I start doing my vertical line test in the other sections, I see that there are a couple different places where it is not a function because it doesn't pass that vertical line test. All right, last thing. It is a you try. I would like you to find a domain and a range for the table and for the graph, and also identify if each of them is or is not a function. Make sure to get your work checked and give the mastery challenge a shot when you are understanding this well. Good luck.